This is a Carboline production.
Have you ever wondered what the role of a coating inspector is and why they are essential to a successful coatings project? Are you interested in the tools that an inspector uses and the advancements that have been made through technological innovation? Have you wondered how drones are being used to not only increase the speed of inspections, but also increase safety for workers? The answers to all that and more are coming up next on The Red Bucket. And we're back. Here we are, the first episode of the Red Bucket podcast. Paul and Jameis, welcome, buddy. I'm glad that we're here. We're finally here. We had our break. We're back.
And, you know, Jack, it is like we never left. I feel like you and I have been sitting next to each other this whole time. It has been great. I really enjoy this new setup, though. The new design, the new studio.
I'm very comfortable in this new chair. I might pass out halfway through if our guest gets a little long-winded, but you know.
And there's no leg rest, so that could be an improvement if we were looking for something to add to it.
Lazy boys.
A recliner.
Lazy boys.
Yeah. Can we put a cup holder in it?
So anyway, if you're new to the Red Bucket podcast, I'm Jack Walker. I am a product line manager here at Carboline. I've been in the industry for over 20 years. I started as a painter. I started on the wrong end of a spray gun, I like to say.
Yeah.
And so then I worked, I decided I liked air conditioning. So I got a job at Carboline and I was painting samples, and then I moved into our technical services department where Paul and I...
That's where we met.
We met and we began to have conversations about podcasts. We would have conversations almost every day. Did you listen to this podcast? Did you listen to that podcast? Right?
Yeah.
And eventually one day I walked in and I go to Paul and I go, all right, I figured it out. We should do a podcast. And now I say a lot of things. Most people ignore the things that I say. And you said, yeah, let's do it. And then it was like, oh, it became real. Now we have to do it. Now it has to happen. So we started a podcast that I joke sometimes is about paint drying.
I tell people, I teach people how to watch paint dry.
Right. I mean, when I tell people in my real life outside of the industry that I do a podcast on paint, there's that awkward silence that follows that statement. And they're like, you have enough stuff to talk about?
Yeah, that's the question I get to.
And I was like, you'd be amazed at how much stuff there is out there. And I hope that if you're joining us for the first time in this journey, that you understand that we look forward to going along this journey and telling you all the things that we have to talk about.
Right. And at this point in our evolution, bringing you other people who have that same passion and interest and knowledge in different segments of the industry as Jack and I do. People who want to talk about it. When you're passionate about things, you like to talk about it, and you usually speak well about it.
Right. And for you guys, you'll usually get a little extra energy, so it'll be less likely that you wreck your car when you're going down the highway listening to us talk about paint drying.
That's right. That's right.
So here we are. Paul, we said I was a product line manager. Tell them about yourself.
Yeah. So I am the director of technical service here at Carboline. I've been here about 11 years, but been in the industry, it's about 25 years. 3 or 4 different paint companies I worked with. I started as a chemist. I was in sales, paint stores, kind of all over the industry, and came to Carboline about 11 years ago in tech service and been the director for the last 7. So it's been a whirlwind of different experiences, different locations. Been in 4 or 5 different states I have worked in for inside the industry, not to mention just traveling to projects and doing stuff. So kind of all over. I've always managed to be headquartered in air conditioning and on the correct end of a paint sprayer, but that was just by chance.
So anyway, enough about me and Paul. If you've been around before, you're very familiar with the two of us, what we are going to bring, not only just in content, but with our own personalities. And one thing that I enjoy the most about the new version of this podcast, if you guys haven't figured it out yet, no time limit. A note on the next portion of this podcast. At the time of recording, Drayton Adkins was the owner of Team Bulwark. Since the recording of this podcast, he has accepted a role as an engineering sales manager for the Great Lakes region for Carboline. So now I want to introduce you to our very first special guest. His name is Drayton Adkins. He's a coding inspector. He's heavily involved in NACE and AMP and SSPC committees. Yes, I named all three. Drayton is the president of Team Bulwark, and they do inspection services. So Drayton, welcome to the show.
Thank you guys for having me. It's a joy and a pleasure to be here.
Yeah, you say that now. It's because the show's just starting.
Man, he sounded a lot like Thomas the Train, flexible and courteous. Anyway, so Drayton, tell us a little bit about Team Bulwark and what you guys do there.
So predominantly a owner's representative quality assurance function in maintenance projects, some new construction, predominantly coatings in the Southeast region and a little bit in the Great Lakes.
So Team Bulwark, where did you come up with that name?
So originally, I'm a sailor. So boats are cool. Marine industry usage for protective coatings is massive. Bulwark is a weird word. A lot of people don't know it. It can mean shield, which coatings are a shield. They're a shield against rust and corrosion. The team aspect obviously sounds cool. You know, we're all together on this team Bulwark. But it's also a part of a marine ship. The Bulwark is a head. It's kind of like a gunnel that allows you to separate the bad ocean from your boat. So that way you don't sink. And we're going to help you not sink.
I feel like you use a lot of made-up words right there. Really, what I want to go back to is, a couple things. Drayton's father, we know very well at Carboline. He spent several years here. So Drayton has that natural connection to this company. And then, Paul, why don't you give us a little bit of a background about how you guys met? Or Drayton, you can chime in too.
Well, and honestly, it was his dad that introduced us. It was way back before Drayton had started Team Bulwark. And at the time, he was just doing some inspection things, I think. And we were at a conference together, and I was talking with your dad, and you happened by, and we were talking. And
yeah, I was pretty new to the industry at the time. I think I was with my second engineering firm, and they had given me the green light to go to the industry functions and start to kind of represent. So I knew my dad would be there, and I was hoping that he'd introduce me to some key players. And, I met you.
And unfortunately, it was me he introduced. Huh?
Yeah,
right.
Yeah. For everybody in the room, he picked you. I'm still not sure why. But it seemed to work out really well. Like I said, I was always interested in the product side of the industry. As an inspector, we get to interact with tech services. We get to interact with people like yourself, but we never get the inside scoop, behind the curtain, as you will.
Oh, yeah. No, we usually draw that wall hard.
With good reason.
Yeah.
Once you see behind the curtain, a lot of the times it's like, I immediately regret this decision. Close that curtain.
That's right.
And so, I know Drayton because of Paul, right? And one of my favorite Drayton and Paul stories comes from Drayton is the head of a drone-related committee for NACE.
Correct.
And Paul, very big nerd, right?
Yeah. Oh, yeah. I own that. I own that.
So Paul decides he wants to volunteer for this committee because, every AMP committee, they all look for volunteers. Everybody. So if you're involved in the industry and you're looking for a way to get involved, these committees are great. But my favorite part is they're going around the room asking everybody why they're at this drone inspection meeting. And Paul says this to a room full of people.
He said, well, I have no drones. I have no inspections that I do. I'm just a nerd who likes drones and thinks they're cool. So I wanted to hang around with people who work with drones.
Well, yeah, because
they're cool.
They're cool. So anyway, we're not ready to talk about drones yet. We're going to get there, but I do think it's neat to understand where people know each other from.
Yeah.
Right. And so with me and Drayton, the first time, I probably had met him once, and then he comes up to me and he goes, I hear you're a musician. And I'm like, this kid goes so many places. And really what it came about was the previous show I had done the theme song for. And somehow you knew that.
Yeah. Again, my dad, he's the key to everything.
And so we had a nice little conversation. And when you meet another musician, you immediately, I don't know about you, Drayton, but the first thing that comes through my mind is he better than me?
Oh, no. The first thing that goes through my mind is I'm definitely better than him.
So there you go. And then I immediately begin to be like, well, yeah, I kind of play guitar a little bit. But anyway, that's kind of Drayton and I, as he began to give me his background of life, not in industrial coatings, I realized how much we have in common. We both did the band thing when we were young, had to get grown-up jobs, and moved on from there. So Drayton and I have a good bond from that aspect of our lives as well. So let's talk about inspection. That's why we're really here. We want to talk about just the basics, some of the tools, what inspectors are expected to do, but we're also going to touch on advancements in the industry when it comes to some of the technology. So I think the first thing that we should start with is, what do we mean when we say coating inspection?
Well, so obviously, since I own a company that does this, I'll start. But, the first thing you have to realize is that reality is going to be different for different parties in the industry, right?
Right.
So when we say coatings inspection, we mean that we're going to inspect the coating that's on there. On what? Anywhere. I mean, coatings are such a major part of life. They're probably in any room you're sitting in, anywhere in the world, you can identify dozens of coated pieces of equipment. For us in the industrial coating space, a coatings inspector usually is involved in the planning and the inspection and testing of work that's performed on a specific project. My personal experience is mostly in maintenance, like I said, but, I was never a rep for a manufacturer. I was always either a quality assurance rep or a quality control rep. So for us, the inspection portion is planning and actually performing the tests required to generate data on what work was performed, and usually to compare it to a specification that was not written by the coatings inspector.
Right. That's usually a key thing that gets overlooked a lot, is the work that an inspector is doing truly should be as a third party.
Right.
You weren't involved in the manufacture of the paint. You weren't involved in the writing of the specification. You may have audited it. You may have reviewed it. You hopefully discussed it with the owner or with the engineering team, but you didn't write it. It's not yours. There's no personal ownership. So you can be unbiased and stand back and look at everything objectively and be able to give input as to what's going right, what's going wrong, and how is this going to perform.
Yeah, I think that brings up a good point. But what you described there is really the idea of the best practices. And I think one of the things that we commonly forget when it comes to inspection is it's not only the end. It's the beginning, the middle, and the end. The inspector is involved throughout the entire application of a coating. So with that in mind, Drayton, what are the best practices when it comes to an inspector?
We have such a ubiquitous credential here where people that are out there doing the job probably don't have any issues doing it, but we've kind of made it a bigger thing than it really should be. So at the end of the day, that's in that AMP course you're describing, we discuss the roles and responsibilities pretty hard because we want you to know that your job is X. And even though you may have been doing it for 10, 20, 50 years, and you may have a great way to do other things, what your role is in the contract mechanisms, the gears that work together to make a successful coatings project, that's your role here. And you don't want to be a different cog because that you can't dual role that one. So
as you talk about going through the training, that was really one of the things that I struggled with the most. I have always been on the manufacturer side. So when I went through, at the time it was CIP courses, and when I went through to get I'm a CIP 3 or the new AMP level, and I can't remember the name.
Senior Certified Coatings Inspector.
Yes. So as
it makes you sound old on top of it.
Yeah, it really does.
That's great.
But when I was taking the course, a lot of the times I would find that I'd be delayed or tripped up in the questioning because I looked at it as a manufacturer and tech service from a manufacturer, not as a third-party inspector. I was involved.
Right.
I did have ownership in something.
Right.
And it's hard to separate from that, which is why there is the value of having a third-party, uninvolved inspector on these projects.
Well, I think you've hit on something that's really important. And I when I was more involved in the field day-to-day work, I would tell other coworkers this and other peers, who is footing the bill for you, whether or not you are considered third party or not, is still very important in your decision making. So to really try and achieve truly unbiased, absolutely just independent thinking, you would have to be paid by a non-party as well, which is never going to happen, right? So they have no skin in the game. But at the end of the day, there are certain industries where the applicator will provide, per the contract terms, the third party, which can cause kind of a hiccup because they still have the ability to say, well, I'll end my contractual obligation to you and we'll go find another third party.
Yeah.
Right.
And that's why we typically prefer, and in many industries this is standard, where the owner, or in the case of an engineering firm representing the owner, procures their own third-party quality assurance team, and they kind of speak the same language and they understand kind of what we're going for.
Yep.
Well, sure, because if a contractor were to hire you, that's a major conflict of interest.
But it happens in
Oh, yeah.
unnamed industries that I won't mention here all the time.
I'm sure it does. So as we look at inspection, it's more than just knowing what to do and when and how. You know, a lot of it is relationships. You know, you're dealing with a lot of different personalities when you're dealing with engineers and owners and contractors. But on top of that, it's not just that. It's the tools that you use every day. And let's talk a little bit about, you know, an inspector's best friend, the tools that are used when we look at coatings that have been installed.
Batman's tool belt, so to speak.
There you
Yeah.
go.
The gadgets.
Yes.
Inspector's gadgets. I should have renamed
Boy, that
the
was
company.
a fine line there.
Dude,
Yeah.
Dude, yeah, that's there. That's, print the money.
So, you know, obviously you're talking about an industry that's been around. I mean, we've been painting things for you know, time immemorial, but the protective coatings industry specifically predates electronics. So we have started to make a lot of major advancements. The courses that we've been mentioning throughout this episode do teach both the original, the OG, but the bananas, you know,
Bananas, the OG bananas.
Yeah.
which is an affectionate term for a type 1 gauge.
Right.
So, but other people will know what you're talking about.
That is a DFT gauge, and it's magnetic and kind of reliable.
Oh yeah. Oh, they used it for decades.
Yeah,
And in
but
some
it's a lot
cases-
on the reader. It's
Absolutely.
it's subjective. Not really, but it is harder to do.
It is easy to use wrong. And that's where the real
Right.
problem comes in, because when you use it correctly, it was what a lot of the first electronic gauges were compared to see if they were accurate.
Sure.
So what we're talking about is a gauge that uses a magnetic property to contact the substrate, which would have to be metallic or ferrous at this point in order to
Right.
work. And the resistance used to pull it off on the dial will tell you what the thickness of the coating is on top. There's no algorithms, there's no computer chips, there's no nothing. It actually just is dialed in and calibrated to know the spring pops at this number, and that's how we know. It's also intrinsically safe. So
Yes.
it is one of the only ways you can measure dry film thicknesses when that's a safety requirement. It doesn't work upside down. People say that it does. In my experience, I don't think it works upside down. Like
Maybe
overhead.
you have
Yeah.
to be upside down too, and standing on one foot, maybe holding your tongue.
It only works counterclockwise, I've heard.
Oh, yeah.
Yeah.
Okay.
Well, and I think that generally, you know, we say that it works upside down because the magnetic property should work in any orientation.
Yeah.
In my experience, it's so hard to get. You have to be very slow and purposeful with the dial. Since it is a very finicky spring mechanism. When you are trying to do work upside down, you do not have the finesse capable of getting an accurate reading.
And I mean, honestly, you do also have, it's the weight of the magnet coming off. You also have gravity. You're
Mhm.
working with you rather than against you when you're pulling off from the top.
A good point.
Yeah.
See, I knew you were a smart guy.
That every once in a
You-
while, I have something to contribute.
You knew that?
I heard.
I didn't know that.
I mean, I heard it from him though, so I took it with a grain of salt.
Right. I'm a millionaire too while we're at it.
Awesome.
Yeah.
Well, I guess lunch is on you.
That backfired. Anyway, so I'm glad that we're on DFT gauges because this is just one of the few tools. But then, like, you know, technology came around. So the banana gauge that a lot of people call it, that's because they're long and a lot of times
Curved.
yellow.
They're
And they're curved.
They look like a banana. So then we move on. Technology comes around, and the gauge is almost very similar. It still uses magnetic for a Ferris
Sometimes.
gauge. Yeah, right. So talk a little bit about the Type 2 gauge.
So, and yes, so this is what you're going to see all the time, almost everywhere, and every foreman have them. Obviously, your inspectors have them because it's a really, really easy, quick way to check the dry film thickness on a coated substrate. We have computer chips in these, so it works on non-ferrous metals too, using a different property, obviously,
Correct,
other
right.
than magnetism. But they do have dual gauges that will read both, and there is a different setup and different verification of the calibration in the field. They work very similarly to the Type 1 gauge, but you have to do different verifications. You don't have to account for the bare steel, which I think we might get into later with the profile and and the peaks and valleys that hide that extra paint that no one knows where it goes, I guess. But the Type 2 gauge in general has allowed everyone access very quickly to a number that you can compare. So it's a major advancement.
And one thing I don't want to let it slip through too easily, the nuance in the words that Drayton just used of we validate the calibration of the electronic gauges. Mm-hmm. We technically do not calibrate electronic gauges in the field. We validate that they are properly functioning. With the banana gauge, you calibrate it. It is something that you can adjust for your conditions. On the electronic gauges, you validate it. And so when that is just, it's one of those nuances that comes up. People say, I calibrated it on here. You slang term it all the time. But when it comes to an actual report, that's not the word you want to use.
And to that end, you will hear us talk about the certain types of vernacular that we use because we live in a litigious society.
Absolutely.
I was just going to say.
And being able to purport yourself as the inspector, you're required to display certain levels of professionalism and understanding the vocabulary and the jargon. You really cut your legs out from underneath you if you tell a jury that you calibrated it in the field. So,
and and that goes all the way down to through the courses. They are pretty hard on shall, should, could, would, may, must. Those words have meanings. When you use them, you have to understand what those meanings are and use them properly. Otherwise, you kind of lose the effect of what you're going for.
Are we bringing back our favorite catchphrase of words have
meanings?
Yeah. They really do. And you can tell, especially when you deal with somebody like Paul or myself who spent a significant amount of time in their job reading very technically written documents.
Yeah, they're not thrilling reading.
No, in fact, if we have any insomniacs out there, I highly recommend Google any paint standard. Start at the beginning. I defy you to make it to the end.
Yeah.
The older, the better, too, because
Really?
we've gotten a lot better about getting to the point faster. But some of the older standard editions that have come out, I've had to read because of older projects and stuff. And I'm like, wow, these guys are verbose.
Yes.
And they are using some esoteric jargon.
But that could be the difference in a job.
Absolutely.
It's the minor differences.
Yeah.
It's a Royale with cheese.
We live in the minute details as inspectors because what we have to do is we have to take the specification and we have to translate what somebody who's probably not involved in the job anymore, their opinion and what they wanted to have happen and come to fruition on the actual job site. We have to know and read what they meant. And if they say something that is very esoteric, it has a very specific meaning, and we want to try and achieve that meaning.
Yeah.
Right. And you don't want to leave things that shouldn't be up to debate. Opinion shouldn't be fact.
Right.
We're talking about construction here. I mean, if we can debate something, it can't be the length of something or the weight of something.
Sure, exactly. So then we've kind of got off on a tangent there, but it was a good one. So I appreciate the conversation. But there's other tools besides DFT gauges that we use as inspectors. Let's talk about a few of those, Drayton.
One of the most important parts of a coating system is its ability to cure and get to its hardened state. So atmospheric conditions that the coating lives in is probably one of the most important stats that we're going to need to document. And we use several different types. There's an old thing called a Sling Psychrometer.
Also intrinsically safe.
Yes, it is. No moving parts, but no electronics.
No electronics.
No sparks. It consists of two thermometers. Basically, one of them has a wick on the end that you wet, which allows evaporative cooling to happen, which measures the wet bulb temperature, and then a normal thermometer next to it. And you sling this guy around. There are different standards for different timings and how long you are supposed to go. But at the end of the day, it gives you two numbers, and you can use psychometric tables to determine a lot of different data points.
It kind of looks like a set of nunchucks.
That's where I was going.
I mean, you just think about, Michelangelo from the Turtles just swinging his nunchucks around, eating his piece of pizza. That's literally what you do because you have to sling it around for a predetermined amount of time.
You may as well have pizza.
Might as well have a piece of pizza in your mouth while you're doing it. Yeah.
Well, I tend to have to switch hands because it is quite a long time that you're supposed to swing it. And I pride myself on being correct. So, I am counting in my head. I'm, 3,100, 3,200. It keeps going. So.
And the thing that I love the most about the Sling Psychrometer is how brilliant it is. It is very simple.
Oh, absolutely.
Like when you look at it, it's like, okay, so if we put water on a thermometer, it's going to cool the temperature and it's going to give us an ability to figure out humidity in the air just by having a wet thermometer and a dry thermometer. And I get lost in those things sometimes. Like, where did they come up for this and how did they know how to make it work?
I usually tell you how much humidity is in the air by how much sweat is not drying off my body.
Sure, you know, we do live in the Midwest where humidity is just part of our thing.
It's there.
Yeah. So there's been an evolution there as well. Drayton, let's talk about that.
Yeah. So digital hygrometers or, digital environmental measurement gauges, they have all sorts of different names. Some of them include anemometers for wind or wind meters, if you prefer, which, you can get from a variety of $10 or $20 all the way up into several thousands of dollars to measure more accurately, more quickly, et cetera, et cetera. The amount of environmental conditions a coatings inspector should take in his day-to-day work is quite large. So, the Sling Psychrometer, while being very effective, very simple, and intrinsically safe, does take quite a long time to work. And having the electronic meter can be savings in the thousands of minutes that you would have on a job, having to go through these things over and over again.
Yeah.
Also, the Sling Psychrometer usually only measures ambient. The electronic gauges often have a thermocouple or a IR thermometer attached to them, which will allow you to put surface temperature in the equation, which will give you another couple pieces of information which are important, which is the surface temperature to dew point, which the industry standard is actually 5 degrees of separation.
Right.
Now, that being said, the 5 degrees of separation is, it's a factor of safety there. Not being on the manufacturing side. I'm sure Paul has some fun stories about that not having to be the case, but we'll never go on record as saying that.
No, absolutely not.
5 degrees at all times, at the very least, and rising. So there's an interesting part when you talked about the way it's written and what it means. So 5 degrees and rising means that technically at the end of the day, when you are falling, when it hits 5, you have to stop. Not at 4, at 5.
Yeah. And again, that's in the nuance of the words. They have their meanings and the way that they're put together is specific to what it is. And we do a similar thing with concrete. We say when you're doing concrete, you want it after it's reached its maximum temperature so it is no longer outgassing. Concrete, it breathes. You can almost consider it a living organism that you're having to work with because of how much moisture goes through it and all the open capillaries that are in it and how much it breathes. So you want to wait until it's heated all the way up, no more outgassing coming out, and now it's starting to cool, and it's going to suck everything back in, and all of the effects of the coating that are on it will help to be drawn deeper into the concrete rather than outgassing and blowing away from it.
I like that you brought up concrete because so far when we've talked about tools that are used either during application or after application. The during application, we're checking our environmental levels. The after application, we're checking our DFT levels. But concrete, we have to measure for moisture before we put down a coating. And there are several different ways to do that with several different instruments. And it just gives you, like I said previously, that inspection work happens before you apply, while you apply, and after you apply. So surface preparation is another thing that inspectors are usually required to sign off on. Do you want to talk a little bit about that aspect of the inspection process?
Usually when we talk about surface preparation, we mean two things, both the profile of the teeth action that the mechanical bond will have, as well as the cleanliness, because there's stuff in the air, there's moisture, there's oil, there's grease, et cetera, et cetera. So, first we've been talking about the older methods, so I'll go through with the Testex tape, which is a brand name, which I don't think there's a competitor, so we just have to call it either. Yeah. You just have to call it Testex tape.
Yep. Right.
You've seen it, I'm sure, on the job sites. It's a little white box, and you take it out and you put it on the steel and you use a burnishing tool, which is its actual name. It's a swizzle stick or whatever else you've heard it called. The burnishing tool, and you will impress the Mylar film into the surface profile so that you get kind of a copy, which you will then remove and take an anvil micrometer to test the replica tape of the existing profile, dialing it back 2 mils to compensate for the compressible portion of the Mylar film. And then you will have a...
And the best part here, everybody, is you would think he is reading it, but he's not. I'm sitting next to him.
He knows all these words.
That was just rattled straight out.
It was great. So, but, again, rudimentary, right? But works. It works so well. But it's evolved.
Yeah, it's evolved. So, and strangely enough, there's actually quite a few different methods in the ASTM for surface profile. A lot of them we don't see a lot, and
Sure.
I've never seen, actually. So there are methods A, B, C, D, and I believe now we've taken away the ASTM for the pencil stylus and added it to the original surface profile. So there's actually, I believe, 5 methods. Test-X tape is the most common one because it's relatively cheap, barrier to entry is small, and the human error factor is actually quite low.
Yeah.
But when we talk about data points, Test-X tape is usually the average of 2 tapes per spot, while the next thing that it evolved into was a surface profile gauge or profilometer. This uses a very small angled needle to get into between the profile peaks and valleys, where it measures over 10 times specifically, and then gives you an average, which is the maximum reading at that point to be analogous to the Test-X tape, which reads the highest reading.
So, very similarly, like that, the profilometer gives you multiple readings over a short period of time or short distance. There is a very similar tool. We're going to talk a little bit about DFT gauges here for a second again, because the next evolution of DFT gauges involves scanning technology, which is very, very similar to what kind of what you described in the profilometer, in that over a short distance, it gives you a significant number of readings.
Right. And you know, obviously, when we're talking about gathering data and actionable data for these types of projects, the more we can get and the more accurate it can be, the more accurately we can predict that service life of that coating, like you said originally. So, in the profilometers are actually not that new. There's a pencil type as well that you've seen. Its accuracy is relatively limited, I think plus or minus 10%, which is unfortunately too large for actionable data. But you see it as quick spot checks sometimes. And then I believe there's one more, but again, I don't see it very often in the field.
Right. And so when we talk about the scanning technology a little bit, that gives us a lots of readings in a very short time. But I kind of want to move on to what we all really came here to talk about. We didn't want to, you know, all that stuff is very interesting and stuff, but
Mylar film.
let's talk about them flying robots.
Yes. Which is a good segue from the scanning probe.
Right.
Because we're looking at the ability to be able to take more readings in a shorter time period, and honestly, in a lot of cases, putting less people in risky or dangerous situations for a working environment.
Well, it's really the evolution of technology, right?
Absolutely.
It's as we age as a society, how does our technology grow with us?
I'm not that old.
I said as a society.
Yeah. I'm in it. I'm in a society.
You're wise.
But as our technology and our knowledge base grows, we begin to look at ways to make things easier.
Absolutely.
So when you think about a drone and you think about inspection, you immediately think about things that are way up high in the air, right? That's immediately what comes to my mind.
Yeah.
And previously, if somebody wanted to inspect, even visually inspect, the top of a water tower per se, what do they have to do?
Climb the water tower.
Right. Now what do they have to do?
They could fly a drone all the way to the top. And you have very good cameras now. So we're talking about the ability to zoom in. There's some debate on whether or not with 4K and 8K cameras now, are we at some level of magnification now, being able to zoom in? I mean, we're talking about seeing a speck from 40 feet away.
Yeah.
And that's not even phase 1. You can get into phase 1 cameras on drones that it's an insane level of detail.
My cell phone has 100x magnification.
Yeah, that's nuts.
Right. I mean, and that'll fit on a drone.
Oh, yeah.
You know, so just the ability to be able to truly look at it. Now, one of the things that's noted in a lot of standards, when you're doing inspection, it is unaided eye. It is in a predetermined lighting factor. Correct. Sometimes you have to bring in light. Sometimes you're using ambient lighting. Right. And it is normally at arm's distance. You're not looking at it with a magnifying glass from 4 inches away. You are looking at it arm distance and under normal unaided eye. Whatever, if you wear glasses are fine, but your unaided eye to see standard thing. Is that standard now?
We have to translate older standards for new technology.
Yeah.
Drones are the wild, wild west right now of the industries that use them, which are varied right now.
I mean, but they use drones for more than just visual inspection, right? Like, what else are we starting to do with drones?
So within our industry alone, we're using ultrasonic thickness gauges. We're using dry film thickness, which is contact-based measurements. Outside of our industry, drones are doing wildlife counts for endangered species. They're doing vegetation counts for farmers. They're applying pesticides to those same crops. And we have different types. So there's quadcopters, which are the typical drones a lot of you have seen with the 4 rotors on each corner.
Sure.
But fixed-wing drones have existed for a very long time, but they're a little harder to fly. They go a lot further as well. Yeah. So, you know, in the agricultural scene, you do see a whole lot more fixed-wing VTOL stuff, vertical takeoff and landing. But in our industry, you see quadcopters because their hover capability is incredible, and we have to stare at the side of a bridge for quite a few minutes to determine whether or not we're getting what we need.
That's right. And they also give us that ability to go in and out when you need to get up close to something and move away before you move over, which is what has led us to be able to do things like dry film thickness testing.
Sure.
With this kind of, you know, proboscis, if you will, that is coming off of the drone.
There's a 50-cent word.
Yeah, yeah. The proboscis is, you know, allows the gauge itself, which, you know, your DFT gauges are also like that. A lot of them are compact, but some of them have a long cable, which allows you to reach into smaller, like, you know, box channels or whatever complex geometry you have. The problem that we get into in some of the more complex geometries on large scales like bridges is drones don't navigate very well when they can't communicate correctly with a GPS satellite.
Right.
So the complex geometries involved make it very interesting because traditionally drones have been, flight aids have been driven by GPS satellites. You get 7, 8, 9 GPS satellites to lock in, and it allows your drone to kind of know where it is, know what it's going to run into soon. And then sometimes on board there will be cameras or usually IR sensors that will help it, you know, figure out its distance. Mm-hmm. You know, consumer level drones at this point have pretty good obstacle avoidance for normal things, but
no, they don't. Mine ran straight into the tree. It does not avoid anything.
I don't think you spent enough money on that one.
Oh, okay.
Well, you know, you get
I'll
what
tell
you
my
pay
wife
for.
that I needed a better one.
You know,
yes,
yeah.
I will go on the record right now, Mrs. Jamis. We need a better drone for Paul at home.
That's
there
right.
we go.
So at the end of the day, you know, there has been a lot of advancements. Drone technology currently, some manufacturers, non-contact based manufacturers, but another American-made manufacturer has 4K cameras on every corner up and down. So it's like 18 axes of vision. And onboard camera or onboard computer parses that data and builds a 3D model internally, which allows it onboard with no GPS help or anything to avoid obstacles. Its obstacle avoidance bubble is like 3 foot, which means you can go like in between trusses at this point. You can really access some of those harder to reach areas. And in some cases, a human wouldn't even be able to get in there regardless. So more effective in the inspection space for sure.
All this while your human assets are on the ground and safe.
Correct.
So we've talked a lot about like what we do with drones, but in order to do these things and do these things in a easy to replicate manner for, you know, people all across the world at different job sites, we have to start looking at standards when it comes to inspection with drones. And so, Drayton, I believe you're the head of a committee that works on this for NACE?
Right. So a legacy NACE document that's going to be a technical report. We did a lot of debate internally on whether or not the industry was ready for a standard, and generally the consensus is no. The capability for technology advances in leaps and bounds so quickly that with the constraints of the standards committee, it would take so long to get to market that it would be probably irrelevant. Even now in the committee that I've been on, we have seen the contact-based measurements we spoke about come to market, which it wasn't in the beginning. So we're already adding new paragraphs at the back of it.
Not to mention they have people like me on the committee that just keep slowing it down when I ask questions.
What was that again? Can you tell me more about that? I'd like to write it down.
What do you mean by flying?
Yes. Well, and, you know, speaking to that and the rovers and the crawlers, we originally titled it Autonomous Robotic Vehicle Inspection or something. It was a really long-winded title, and we got a whole bunch of people that showed up to the first meeting. And I was like, wow, people are really interested in drones. And I found out the majority of them were for undersea magnetic crawlers, pipeline crawlers, and then the numbers dwindled a little bit. But that was because, again, with those correct words that matter. Words have meaning.
Words have meaning, yes.
So we did get rid of rovers and crawlers and underwater. Those industries tend to self-regulate pretty well.
And they've already got a bunch of guidelines that they follow with those.
Sure.
Yeah, exactly. And so with atmospheric, or even in some cases, I would say, not atmospheric, but buried pipeline that will be uncovered and then we'll fly inside of the pipeline with the tiny drone that we have.
Yeah.
The reality here is that we're talking about speed of inspection, safety of the inspectors, and the ability to impact the public less. And the list of pros goes on and on and on. But we have to standardize something if we're going to use it as a tool. All the tools we mentioned that an inspector used previously have a standard associated with them, oftentimes several standards associated with them. This gives us all a level playing field to really use the data to compare what we want and what we have. So when it comes to the drone, we're not going to come out with a standard, but we are going to come out with a technical report and kind of let the industry self-govern how we can use these to the best effect, because we're just, half dozen people in a room, and we want to get to how can the industry really take this technology and make it better.
Well, on that note of having the standards for the pieces of equipment that we already have, in a case like the drone doing dry film thickness testing, we're not changing the dry film thickness testing equipment, the reader, the standards, any of that. We are only literally changing the, dare I say, hand that is holding the equipment as it contacts the substrate. So we've changed it from, Drayton's hand pushing it straight onto the thing, and his hand is now a little further away on a remote control, and there's a stick pushing it onto the thing, or what's it called? A
proboscis.
Proboscis.
Well, there's an evolution there that naturally happens, and as this sees more market saturation, the use of drones for inspections, what's really happened is that market saturation has led to the point where the government has noticed. Recently, just passed in the Senate, sent back to the House, is called the Drone Infrastructure Inspection Act. And what this is going to do, Drayton, why don't you talk a little bit about what the goal is here with this piece of legislation?
First and foremost, I think that government entities have noticed that infrastructure in America may need a little help.
Yeah.
And we have realized that it can be really, really time-consuming to both inspect all the assets, create plans to repair and maintain the assets, then go in and actually perform the repairs that we found out that we needed. But actionable data is important here because we want to get to the answers very quickly. The Drone Act will allow some money, I think about $100 million.
That sounds right.
Yeah. Just a small sum of $100 million.
That's my Friday entertainment budget.
Yeah, again, lunch is on you.
Right.
So a small portion of that will go towards, the largest portion of that will go towards manufacturers that are based in America to help a little bit with the economy of scale so that we can get more drone manufacturers involved locally in the United States. And then the other portion will go to training and inspection training and being able to use these effectively.
So with that being said, how much do you expect once this gets passed and they put some money into this market? One of the things I wanted to talk about is how frequently do you see drones used for inspection currently, and what do you think this bill is going to do to the number of people using drones for inspection?
So I don't see a lot of it, especially not in the coding space because it is mostly visual. But in the ultrasonic thickness testing and in some corrosion monitoring positions, it is being more prevalent. Certain DOTs have made it public that they would like to continue doing these things. I believe the Arizona Department of Transportation is mentioned in the current act, was headed up by an Arizona legislature. And the North Carolina Department of Transportation is using drones from a certain American-made manufacturer to great effect right now. We're doing a lot of BIM, 360 modeling, digital twin work, in the design and engineering space. So we're already gathering a lot of the data that would be necessary for coding condition assessments to take place, but we're not connecting the people who can do the assessment, the subject matter experts who can review this visual data and make some calls with the people who've already gathered it. So I believe that once you see this come to light, there will be more people willing to take a step in that direction. Generally, it's been the behemoths that have had the ability to do R&D work to get there to see if it will be a functional aspect of their work flow.
All right. Well, this has been an amazing conversation about inspection, about drones. We've covered a lot, but I want to get to a little bit of fun that we're going to have.
Yeah.
And this is something that we're going to do every show. We're going to ask these 4 questions. We're calling it the 4 questions segment. And here we go. So, Drayton, what's your favorite movie or TV show?
A little known 1989 number by the name of Hackers.
Yep.
It stars Angelina Jolie and David Lee Murphy. I can't remember his name. The other guy, he did some stuff. But Angelina,
There was a guy in it.
Yeah, there was a guy, but mainly Angelina Jolie.
Isn't that back in the time where they made all these movies? Computers, and they're scary.
Yeah.
Yes,
It was
that's-
always green dots.
Yeah.
Yes. It was pre-Matrix, pre all of that. Actually, I think The Net with Sandra Bullock had already come out
Right.
a year
Okay.
prior.
I was thinking of that one specifically as they're like, I got an email. Ah! You know,
There was an attachment.
Yeah.
What does that mean? How do I shake the attachment?
but that tells me a lot about you, actually, that Hackers is your favorite movie. Moving on, Paul, you want to ask him the next one?
Yeah. So, okay. Sports. You got a sports ball thing that you like to watch?
My personal upbringing was I played soccer as a small child and picked a lot more daisies than I did goals. But I do enjoy watching. I like college sports. I'm a hockey fan. My dad's from up north, so
Okay.
I grew up watching hockey. And it's contact-based. That's always fun.
All right. Hobby. So when you're not flying drones, looking at paint dry, what do you like to do?
Well, you mentioned that I was a musician, so I guess I'll skip over that one because that's boring. I am an avid motorcycle rider.
Really?
Yeah. And sailor. I like transportation modes.
And those two don't normally go together. One goes real fast and one does not.
Well, yeah, you don't want to do them the same day. You might just want to have a relaxing day on the water. Or you might want to have a high, fast-paced action adventure Mission Impossible scene in the mountains.
The very last one, and this one is, I like this one. This is as a musician, as a wrestling fan, as a baseball fan. If you were to have a walk-up song, what would it be?
Well, as an avid musician, the songs that you listen to every day change, right? But
Right.
currently, right now, the thing that I get up in the morning and listen to on the way to work to get me pumped up is Industry Baby by Lil Nas X. So that would be my walk-up song.
The
But for
Old Town
wrestling-
Road guy?
Yeah, the Old Town Road guy, but not that song. I would use it for wrestling, though, not for baseball.
Drayton, thank you very much for coming on the show. I think it's been very informational to our audience. I learned a little bit. Paul, you probably learned a little bit yourself. And we look forward to seeing you again in the future. And as always, it's a great time talking to you.
I can't thank you guys enough for being here. I listened to the podcast, as you mentioned before, and it's a dream come true for a little paint guy like me.
We're happy to be a small part of it.
Thank you guys so very much.
Thanks, Drayton.
Thank you. And a part of the Red Bucket podcast is this new segment. We're calling it Tech Tips.
That's right. This is an opportunity for some of the guys in tech service or other people around the company or in the industry to be able to give us little tips as to how does a job go easier? What can you do to make your workspace better, easier, function more smoothly? How do they see it? I've got a team of guys that work with me in tech service who this is what we do all day long is we talk to people, we pick up these tips and tricks. A lot of the guys came up in the field is how they got their experience. Or in application groups or something to that effect of these are tricks of the trade that maybe not everybody thinks of. Some of them are straightforward and half of the people in the audience are going to go, well, yeah, but there's going to be somebody who realizes it and goes, oh, that makes my work so much better or easier. And that's the goal of it.
Well, and, part of this podcast is to introduce people to people within the industry. So what better way for our audience to get to know the technical service team here at Carboline? So here's that segment. It's called Tech Tips.
You have questions, they have answers. This is Tech Tips.
This is Brian O'Connor with Carboline Tech Service, and this is my tech tip of the day. When working with coatings on concrete, it is a good idea to put a drop of water on the concrete. If the water beads up, the concrete will not accept the coating. If the concrete absorbs the water, then it can accept the coating.
All right, and that does it for the first episode of the Red Bucket podcast. Paul, I had a blast.
Jack, this was a great experience. I really love the new format.
I really hope you guys enjoyed it too. For Paul, I'm Jack, and we'll be around next month.